Let's get started with Agile methods. Agile methods are the software development lifecycle methodology that we will use this semester. Some reasons for this. First is industry relevance. Recent study showed 88% of projects just starting or have started in the software industry are using Agile methods. Really kind of the latest software craze. Another reason, though, and a reason for this specific class is the software quality construction techniques that we're going to talk about are largely associated with Agile methods, in particular extreme programming. They weren't necessarily created by that community, but they were certainly adapted, incorporated very tightly. So when you go to an Agile shop, more than just seeing extreme programming, more than just seeing Scrum, you will see these construction practices commonly in use. So it's an appropriate process model for this class, given our emphasis on software construction and transition. So that being said, I called my first talk on Agile methods kind of the Kool-Aid talk. If you're familiar with the phrase "drink the Kool-Aid," that's what this is about. It's like a lot of things in computing. We talked about it with IDEs. Everybody's kind of got their own opinion or quote-unquote religion around what they like. The Agile community is no different. When you talk to somebody who's an Agilist who's been certified, it's a very chummy, reinforcing community. Agile methods didn't really bear out of a lot of theoretical research or foundation in academia. There's some I'll talk about. But really out of a community of practice. And so Agilists tend to have a lot of fervor and excitement about their methods. I encourage you, by the way, to look for Agile user groups in your community. For example, here in Phoenix, we have the Phoenix Scrum Users Group, which I try to go as often as I can, meets once a month, has some great talks on Scrum and all things related to Agile. So I suggest you try and look for those kinds of opportunities in your own community. All right, let's jump into it here. If I can get the slide to go down. Just a moment. Okay. So first, and I like to start a lot of my talks this way, some inquiry questions, some questions for you to think about. First is, how do you think a typical project, a typical software project is run in the real world? We'll talk a little bit about that. What are some common process features of software lifecycle processes? At this point, you should have been introduced to various software lifecycle models, waterfall, spiral, RUP, things like this. But if you step back from those models, what are the kind of common features that you see of those different kinds of processes and how they kind of evolved over time? And then we'll talk about those kinds of things in the context of Agile. Why do software projects fail? And this is something I'd like you to kind of research on your own. And certainly there's a lot of reasons software projects fail. But we're going to talk about it particularly from a process perspective, if you will. And then, how is Super Mario Kart like Agile methods? So when we talk about how typical projects are run, what common process features are, why projects fail. We're going to talk about how Agile is a little bit different, also kind of how it's the same, and use an analogy of our Super Mario kind of being how we run an Agile project, and hopefully that'll be a little more clear when we talk about it. So, how the typical software project is run in the real world? Well, there you go, hair on fire. Well, not really, but software engineering has not been how should I say it, well reputed for its ability to manage its projects like other engineering projects, for its ability to bring projects in time and within budget, and not have significant quality issues. The general approach and history of software, I realize that software engineering is a relatively young engineering discipline compared to other, civil. Humans have been civil engineering since the caveman days, right? Mechanical engineering, even electrical engineering, relatively young, but still older than software engineering. Software engineering is going to come up on its 50th anniversary in a handful of years, about a half dozen years. That's not very long for an engineering discipline and engineering practice to have been around. So as it's gone through its evolution, as it's gone through its engineering approach, the software lifecycle models are a big part of that. Some of the history of trying to use other engineering process models and how they relate to software engineering been somewhat difficult. Software is invisible. Software is not designed. It's not constructed the same way. You can't reach out and touch it. So its methodologies have been, have evolved in almost an independent way than traditional engineering disciplines. In any event, what effectively happened is starting in the late 80s through 90s, there were really the approach had gone down a path of adding more and more overhead, meaning more. Think of overhead. What we mean by that is more and more activities not related to actually producing software. There were more and more documentation activities. There were more and more requirements activities. More and more audits. More and more verification activities. The approach to the problems in software engineering, those budget overruns, those quality issues I was referring to, was kind of that we need more process, we need more stuff, we need more documentation. We've got to basically keep trying to constrain things to manage the churn that naturally happens in a software environment due to that invisible, I can't reach out and touch it nature of software. In any event, there was kind of started to be a backlash against this. People were doing more and more of this with, I wouldn't say no return, but not getting the return they wanted. Software has always been a time to market type discipline, how fast you can get things out there. It's always been very difficult to estimate and create budgets around software projects. So these kinds of frustrations in adding more and more process with little return kind of led to a backlash. Think of Agile kind of started to evolve as a community of practice saying, enough is enough. We have to start thinking of better ways of developing software to, really get back to producing excellent software products, doing it within budget, doing it under the time to market pressures that are natural to the domain. So when Agile methods came about, they decided, well, one, we're gonna go back to focusing on the code rather than big requirements documents and big design documents and all the audits and reviews and I'm going to try and narrow or eliminate this concept of change. We're going to go in another direction. We're going to put the focus back on the actual number one primary deliverable, and that's the software code itself. Second, based on an iterative approach, Agile didn't invent iteration. Many at the time of the thinking, folks out of the systems world and who were waterfall driven started just to think in terms of doing things iteratively and incrementally, which we'll talk about in a minute. And in order to try and understand if they were going directionally correct and to avoid big bang integration issues, the focus was on delivering working software quickly and evolve it quickly. In other words, always have this continually releasable software notion. And I will say it's after going on about 15 years of the rise of Agile, if you will, in software engineering, folks are really starting to actually get to this point where they can actually start delivering software featuring in a very rapid basis. It's beyond the scope of this class to talk about advanced Agile and lean methodologies, specifically things like Kanban. However, realize that that's kind of the direction that things are going. Folks are trying to get to the point where they can release software every day if they can. And so, that time to market pressure and how Agile addresses it, another reason for the rise of Agile methods. So the aim of Agile methods, reduce overhead, all right? Try and only do as much of the requirements design, documentation-driven software engineering as is needed for your particular project and no more, and instead focus on the code, and then use mechanisms like iteration sprints and things like that in order to respond quickly to change as opposed to thinking that you're going to eliminate change. Okay. Some common features of software development lifecycle processes. And again, you see some of your lifecycle processes here in the middle, kind of mini graphics of them. Hopefully you can make those out. And I'm not going to review each one of these. I'm presuming that you've had some exposure to most of these. Our waterfall model over here. From the water, you see the classic thing of the waterfall is, this kind of phase by phase focus. And anytime you would have a defect in one of the phases, you got to go back to that particular phase and start all over again. So if you got to operation and maintenance, meaning you put it in the customer's hands, turned out some design flaw was discovered, guess what? You got to stop the world. You got to go back and do, you got to fix the design phase all over again and then go forward all over again. Very costly, not very good for time to market. However, for all the folks waterfall bashing, waterfall is relatively easy to manage and relatively easy to track compared to things that have a lot of iteration and increments to them because there's a lot of things going on at once, and Agile's no different than that. One of the ways that folks tried to respond to problems with waterfall being too forward engineered, too costly, too slow, was to introduce more validation steps, and so they came up with the V model. This V model here has the waterfallish type behavior down this side of the V and has verification and validation activities going down this side of the V. All right? Meaning essentially, let's introduce more of the verification and validation that would happen later in a waterfall process. And let me switch to a different pen because this is... because later, I'm still very thick, sorry about that. Later in a software process, if you're waiting to do your big bang integration and validation activities there, very often these kinds of waterfallish projects would have a problem, a big bang integration type problem, and a very costly rework would ensue. Additional lifecycle models. This is synchronize and stabilize, which was popular with Microsoft. Basically, the adage that you couldn't leave the Microsoft facility until your software built for the night. That brought in a notion of this, of what we'll call in this class continuous testing, continuous building. That notion of a nightly basis. So it had a process feature of doing things incrementally that you see in each row here. That's an increment. But also more frequently doing the iteration part. As I said, in Microsoft that made this popular was doing it every night. RUP was very popular. RUP is probably, RUP has gone more agile because the R in RUP stands for rational, which was acquired by IBM, so now there's IBM Rational. But prior to Agile, RUP on its own was really the predominant, most popular software lifecycle methodology. And if you look at the RUP model, it kind of had this waterfallish hump through each one of these phases, but at the same time acknowledge that within each phase a certain number of every single activity went on. That notion, so for example, you're in construction and transition, and the orange boxes there, I'm going to clean up the ink here so you can see it. This orange one right here, that's the coding line, right? That's the coding workflow. I'm sorry, the yellow is the coding workflow. And in the coding workflow, you would start doing more and more construction as you got out of elaborating requirements and moving into the formal construction phase. But you always did kind of a little bit of everything. So RUP kind of had this compromise between doing all things in parallel, like synchronize and stabilize, and doing things in kind of a, well, most of our time is going to be spent here in the project early on, but we'll be doing a little bit of everything. And RUP went on to define some fairly specific workflows in each one of the phases to define what you should be doing in each phase across each one of these workflows. And then finally, the spiral model. This is a small, blown down version, so you can't see it in its full glory. But if you're aware of the spiral model, the main thing, this was contrived by Barry Beam, very big name in software engineering. And the real thing about the spiral model was one, that it was risk driven. So every turn around the spiral started with a risk analysis project. And the second thing, it advocated a lot of prototyping in order to uncover more information and again try and minimize downstream change that was costly in the rework of the waterfall method. So these kinds of common features would come about. You would have a sequence set of phases, very explicit here in waterfall, what those phases are and what the sequence is. Sequence still exists in the V model. It was just an integration of some new stuff. Even within each increment of synchronize and stabilize was kind of a mini waterfall. As I said, even in RUP, there's this almost waterfallish kind of pattern to the humps if you look from the upper left corner to the lower right corner. Notion of tightening feedback loops, another common process feature. So again, the V model started with this. We kind of need to, we can't just have a box that says QA or testing on it. We need to start doing these kinds of activities, these quality monitoring activities throughout the entire life cycle. Now, the nature of those activities may be different depending on what phase you're in. Isn't just testing, in other words. It could be a design audit or whatnot. But they need to be done and emphasized throughout the life cycle, not just at the end. And second is and part of that is getting feedback earlier. Folks started to realize, even in a forward engineered process, they started to realize, well, if we're going to fail, we have to fail fast. When you do not fail fast, your cost of rework goes up. All right. If I find out I have a requirements defect all the way out here at integration and system testing, well, I have a big issue because I had spent all this money in time designing and implementing against something that was never going to work because the requirements were incorrect. So the notion of failing fast, tightening those feedback loops, another process feature that folks learned that was extremely important. Incremental delivery, something that you should be, it should be natural to you as a software engineer / computer scientist, because basically what incremental delivery is decomposition, and decomposition is a fundamental complexity management technique that you've been taught since algorithmic design in CST100. You take a big problem and you break it down into smaller steps, or in CST200 and 230 from an object-oriented perspective. You're still doing decomposition, but you're doing it from an object-oriented perspective. You're taking a large system and decomposing it into components, into individual objects, and then assigning responsibilities for the system onto those different objects, so those objects can have a conversation to have the emergent behavior that meets your requirements. From a process perspective, incremental delivery basically said we're going to take a big deliverable and we're going to turn it into n number of smaller deliverables and see if we can put an individual little mini process around it and try and manage the integration of those things by basically saying we're going to integrate more often so we can tighten the feedback loop. All right, so another best practice, incremental delivery. Really these two things were somewhat of a reaction to large system integration failures. Basically, envision teams of, and I mean large systems development, I mean hundreds if not thousands of developers and engineers in an organization or spread in a multiple organization kind of contractor subcontractor relationship, and they're all trying to go off and work on their little parts, and then they come back and try and put things together, and the things just won't go together. The interfaces don't match up, the data models don't match up, things integrate, but then they can't meet non-functional requirements for performance, security, resource utilization, all these kinds of things. So these two, managing incremental delivery and tightening feedback loops are fundamental to trying to address that integration problem. And then folks started to realize that doing things in iteration, again, almost a bit of a combination of the tightening feedback loops and incremental delivery. Folks realize that trying to talk about, if I'm starting a large software project today, 6 months down the road, it's going to be hard for me to predict what things look like. I need to work in, and I can only manage against a relatively short time window. Now I have to plan 6 months out, and I have to think of what my release might look a year out, a couple years out. But if I'm going to think about exactly when I need resources and what my developers are doing on a relatively daily basis or weekly basis, trying to predict that 6 months out from today, almost impossible. Not really worth the exercise, if you will. So from an iteration perspective, Rupp and Spiral started emphasizing this notion of doing things in relatively short time periods, and having a formal stop and start to an iteration, so you could do the micro kind of management of planning the next N weeks or N months, and getting that feedback before moving on to the next one. So these are the common process features, and I mention that because in our focus on agility, you might ask, well, which one of these does Agile have? Well, the answer is all of them. In fact, when you learned about software lifecycle processes, hopefully you kind of saw some of these common features emerging, because to a certain extent that all the lifecycle models in software engineering have the same process features or properties. Largely, it's really how they arrange them and prioritize them and define the inputs and outputs against them. Not that they do something different. So for example, Agile really focuses on that when and how of the new phases, almost doing them within the context of a very short iteration, and only doing them to the extent needed, which we'll talk about with the philosophy of Agile. As I mentioned before, a number of the Agile techniques that we'll even talk about in this class, not invented in the Agile methodology, they're taken from somewhere else in software engineering and adapted. So for example, we'll have time to talk later in the semester about something called planning poker, which is a way of estimating your work that's common to Agile projects. But planning poker is really something called the Delphi convergence method, a Delphi estimation method that Barry Beam wrote papers about decades before Agile ever came about. The Agilists just adapted it and made it work in an Agile context through the planning poker concept. And so you'll see me revisit that theme throughout the semester. Okay, third inquiry question is, why do software projects fail? Well, first of all, that's a complicated question. I mean, I'm not going to suggest that what we're going to talk about is the one and only reason that software projects fail. But again, be aware that software project failure rates really have been too high for an engineering discipline, and that's of concern because as more and more of society relies on software, the more and more it's an issue as software projects are failing. All right, so it's under continuing study. The industry is certainly concerned about it because there's dollar signs associated with it, and frankly, there can be human life at stake. Software is driving more of our world. And it's also an academic research question, very active. I do work in this area. Just about every software engineering is trying to work on a fundamental project of how do we engineer these things better so the projects do not fail and the products do not fail. That disclaimer aside, the simplest answer, in my opinion, is because predictive process models are doomed to fail. Basically, looking back at those previous software lifecycle methods, waterfall, Rupp, so forth, they still kind of have this notion of over whatever time period or set of tasks, they still try and basically say, let me try and plan out to excruciating detail the work of my engineers over the next, whatever the time period is, weeks, months, days, whatever. And let's create what's called a predictive process model around that. Now, what does that look like? And I wanted to bring up a blank slide so I can kind of draw for you what I mean by that, because you haven't really encountered that yet. Let me see if I can get the right pen up here so I can draw a little better. Okay. Let me get a better color than yellow because you're not going to see that very well. You can kind of tell we create our materials using a digitizer, and so I have a digital pen and a mouse here, and still getting used to how these things work. So in any event, what do we mean by a predictive process model? Think of any kind of task that you need to do where you have to plan out multiple steps, right? We talked about functional decomposition with an algorithm. I've got big problem here at the top, and take my big problem, and what do? I decompose it into multiple smaller problems. Smaller, I'm drawing with a mouse now. Smaller problem 1, smaller problem 2, and smaller problem 3. In its simplest form, what a traditional project manager is going to do with these tasks as they're broken down, say a work breakdown structure, is they're going to try and take these tasks now and connect them in what order they need to go into. They're going to try and understand all the tasks. I mean, here's 3 simple tasks, but I could have lots and lots of tasks that exist for my project of various sizes, meaning how long I think it'll take somebody to do that, how much resource it'll take to do that. And I'll have different dependencies between these tasks that I'll try and order. And this is emerging, as you can see, into a very sloppy notion of something, if you're familiar with, say, Microsoft Project, if you're familiar with a Gantt chart. This is evolving into something that one might call a task activity network. All right, task activity network. And that's a sloppy A. A task activity network, which you'll learn about in 416 more formally, but effectively it's a partially ordered graph, if you remember that from your discrete math course. And your job is to understand what the dependencies are between different tasks that a team has to do. Maybe the output of a task serves as an input to another task, and therefore this task has to be done before that task. Then there's also a resource model associated with it. So, this resource right here might require your DBA, your database administrator, and this task, let's say SP2 is a task that also requires your DBA. Well, now your DBA can't be double booked. So do you get another DBA? Or do you have to slide this task forward or backward to make sure the same DBA can do that? And you kind of wind up with this temporal representation that preserves the dependencies between tasks and the resources you need to map to make each resource happen. That is a simplification, but in essence, what a traditional project manager will do, so that and then they'll add some wiggle room in there based on how good they think the estimates are, to come out with what's called the critical path, the longest line it takes to get through all the tasks, so they can promise delivery of the project and they can estimate a cost model. All right, that is a predictive process model, meaning we're setting up this entire task activity network and hoping to preserve it as a project executes. Now, what's going to blow up a task activity network? Well, what's going to blow it up is some form of change. Maybe you're here at the DBA's task and any one of the following things happens. Your database server crashes. DBA can't do any work, the database server is gone. The DBA quits or gets sick, and you have to train a new resource and get a new DBA in there, and that takes time, pushes the whole schedule back. Other forms of change. Maybe the entire requirement change. A customer came in the middle of the project and said, I want to do something different, or you misunderstood the requirements or whatever, and this whole set of work right here doesn't even matter anymore. All right? That nature of change happens too often in software projects, and being able to react to that change in the form of a predictive model, all these forward arrows and resource assignments, has simply proven to be too difficult. So, Agile methods, what's different? Embracing change. Basically saying, we know that change is going to happen. Instead of trying to do everything we can through process overhead to eliminate it, we're going to embrace it. We're going to expect that it happens. So it's in part a philosophical shift. Second is we're going to focus on people first over dogmatic process. So one of the reasons for failure is when you look at this sloppy model now, even if you're successful, what happened in a lot of software projects is even folks that were successful with all the things on their Gantt chart, all their things in Microsoft Project, they could check them all off and say they did them all. The problem was they still weren't delivering the overall system. They weren't solving the overall product. There were too many other hidden or unknown activities or things that need to be discovered as you did them. And even checking off all the boxes, we're not giving a true rate of delivering working software to a customer. So instead, you get through the end, the project plan seemed to show that everything was on track. You get close to the release date and you start realizing, wait a minute, even though the Gantt chart had been looking fine, we're not going to be able to deliver our software. That's a problem. So emphasizing the people first and how they're doing on the project and what they feel about project process over a dogmatic set of process steps, meaning checking those boxes off, another big philosophical shift. And then finally, progress in an Agile method, particularly when we talk about Scrum, is measured in terms of our ability to deliver each iteration working software to make more tangible what we're delivering to the customer so everybody can see it and we get that stakeholder input. Again, as opposed to going to the Gantt chart that's become a mess and doesn't represent reality anymore, we're going to go to the working software, and that's going to be our measure of progress. Okay. So what was kind of the theoretical foundation underneath this? Well, I asked you to read some papers by Ken Schwaber, and actually in the one that I labeled on Blackboard as optional, there's an expert there. Ken Schwaber was one of the best practitioners, if you will, influential community members, and wrote the Black Book, as it's called. Schwaber and Beadle wrote the what's called the Black Book for Agile Development and Scrum, which I can post a link to because that's an excellent book for those of you moving forward and interested in Agile. But the paper I posted was kind of predated that book by a couple years and was kind of his first thoughts on it. In any event, an expert from him, he went over, the anecdote goes, and that he went over to Japan and talked to some industrial process control friends, if you will, and kind of talked about how a software project was done, projects he was involved with as a consultant. And the quote down there below kind of captured it. I rarely provided a group with so much laughter. They were amazed and appalled that my industry, systems development, was trying to do its work using a completely inappropriate process control model. They said systems development had so much complexity and unpredictability that it had to be managed by a process control model they referred to as empirical. So basically, define process control, like we just talked about, that Gantt chart, that Microsoft project view of things with a task activity network, where every task is completely understood and can be sequenced and resourced. That predictive, defined process control model wasn't going to work. Too much complexity, too much change. So empirical process control instead focuses on the feedback. It says we're going to have frequent inspect and adapt cycles. We're going to be okay with tasks and requirements, really, that are not well defined or completely understood. And instead we're going to kind of create a momentum or a rhythm, which we'll talk about a lot, to our projects and kind of churn through the work. And if we do some work and discover something, that's just a form of change, and we will embrace that and do something about that. And we'll deal with tasks with unpredictable or unrepeatable outputs. A lot of, if you've heard of something called the capability maturity model in software engineering, a big part of process engineering is about, hey, we need to be able to repeat this process. Well, I can tell you, and it's been true for me for many years now, I've been on software projects with a lot of similarity, but I've never been on a software project that's kind of exactly like something else, where I can truly say that what we need to do in this project is repeatable from previous projects. Getting to a maturity level of your processes in software engineering such that you are truly repeatable, it may happen in some domains, it may happen in some organizations, a tremendous amount of overhead, and you have to wonder if it's worth the cost to try and reach that level of maturity. Okay, that's our kind of our thought questions. Oh, I didn't talk about Mario. Why is Mario on this slide? The whole point of Mario is to say the goal of a metaphor, I didn't say the goal, a metaphor for Agile is to set a direction for a project and to steer. And as long as you can stay on the road and kind of steer in the right direction. I know when I play Super Mario, I keep falling off the bridge and going to nowhere. As long as you can stay on that bridge, you can stay on that road and steer, make those micro adjustments to keep yourself directionally going. the direction you need to go, then you'll be fine. Which is a little different than trying to plan out ahead of time exactly where you're going to drive on the road, like you're a trolley car or a subway or something. Okay? So that's our Super Mario. All right, let's talk specifically. Those are some motivating principles behind Agile and how it, the same yet different than other software development lifecycle models. Let's talk about Agile principles. And this is really, the next few are from your reading on the Agile Manifesto. The Agile Manifesto, again, community of practitioners, expert practitioners. You can read about on that site. They got together in snow country in Colorado or Utah somewhere, I forget where, and kind of had this. We all been kind of converging on these ideas of agility. It didn't have a label at the time, but we kind of realized that there's new ways of developing software, and so they got together and kind of wrote down the philosophical and cultural underpinnings of it. So the manifesto is not a recipe. It's not like Scrum or XP that says here's a process. It's not a process methodology, but it is a description of the philosophy and culture that one should have if they are working in an agile fashion. And so it's important because first, it was radical at the time. Second is there's a lot of places that say they're doing agile. And they say they're doing Agile because they believe that they are adhering to these principles. So you might say, are you doing XP? You doing Scrum? You doing Crystal? They might say, no, we're not doing anything like that. We're kind of doing our own thing. But we're still Agile. And we're Agile because we conform to the Agile principles as stated in the Agile Manifesto. Agile Manifesto stated, we have come to value individuals and interactions over processes and tools. All right, so again, that's the people first aspect. So a fundamental tenet of Agile is that people will work closely together and collaborate to find a solution, and however they do that is more important over which technique they used or which process or whatnot. So even though, for example, there's a lot of papers and things you can read on pair programming, which we'll talk about later in the semester, it isn't so important to an Agilist exactly how you do the pair programming. It's just important that you have those individuals with those interactions working on it. Again, valued over the specifically how you do it, if you will. Valuing working software over comprehensive documentation. Again, having this always deliverable increment of software, more important to show progress than saying, hey, we've documented a whole bunch of stuff, so we feel like we're making progress. Progress is shown in the code. A controversial one, and one that's probably that a lot of Agile organizations still struggle with, is customer collaboration over contract negotiation. And I'm going to talk a bit about this, and your textbook does as well, because Agile in its purest form kind of not only affects your engineering organization, but if you're really doing it soup to nuts, meaning all the way through not just the software lifecycle process, but the product development process, then it comes to affect the way that you interact with your customers, because they have a role in the process as well. And normally that role has a much more formal boundary in the form of a contract. And so the nature of how contracts are constructed and agreements are made between customers and vendors, suppliers of software, needs to change when you're working in a purely Agile project. We'll talk more about that. And then again, we've already talked about it, but probably the number one thing about Agile to remember is it's about responding to change over following a plan. Checking that box and saying, hey, we're making progress because we're following the plan, is not as important as making sure you can respond to change. All right. There's also some, when folks, so you could talk to an Agilist and they will know this. However, some folks I talk to seem to think that, what that means is that Agile, you can't write any documentation. And that's not true. What these folks actually said is below. There's value in the things on the right. There can be value in documentation. There can be value in processes. There's value in contracts. It's just we are going to value the things on the left, the things in bold, more. Some things here, and I tried to highlight some of them already in here so I can go through them quickly. Highest priority is to satisfy the customer through early and continuous delivery of valuable software. That's that notion of always being able to deliver your software at least at the end of an iteration, if not more frequently, as the direction things are going. So there's always that visible notion of progress. welcome changing requirements, even late in development, without having to do the rework. So again, that embracing change notion. Just like the first one, deliver working software frequently, where it's defined in weeks and months, and actually nowadays it's weeks, days, and maybe even hours. The shorter the better. And again, that tightens that feedback loop. Customers, business people, and developers are working together daily. So again, Agile's kind of have pure Agile kind of believes that the customer should be omnipresent, is always there with you and amongst you, and that the practicalities of that are up for debate. But from a philosophical perspective, the customer is in effect part of the team, like something called predated Agile called Joint Application Development, or JAD. Build projects around motivated individuals, give them the environment and the support they need, and trust them to get the job done. Agile was a bit radical as well from the perspective of basically asked account managers and project managers to cede control or empower the engineers. Basically, software developers are saying, look, I got a lot of project managers who weren't engineers or developers or haven't been it in a long time, and trying to have me explain to you the complexities of what I'm doing so that you can update your estimate in that Gantt chart isn't worth it. I'm going to make a commitment to you that I can get this done, that I'm going to figure out the way to do it, and I can do it in this time frame, and I'll take the accountability for that if you trust that I'm going to get that done. And that actually was, along with the contract aspect, was kind of one of the things why Agile didn't immediately take off. Agile's been around for a while now, but it didn't immediately catch the world like wildfire like it has in the last half dozen years. For a while, there was a lot of skepticism that Agile could work for a lot of projects, precisely because project managers didn't want to cede that control and visibility into their projects. And it wasn't until ways emerged that project managers actually saw they were empowered with greater visibility into their projects that they started to accept this new way of doing things. Okay, the most efficient and effective method of conveying information to and within a development team is face-to-face conversation. So far we talked about Agile, values working software over documentation, and I talked about it in the context of a document is not software, right? A design document doesn't give the customer any functionality to do anything with. It's the actual working delivered software product that matters, and that's why Agile is valued over it. Well, there's kind of a second reason too, and you'll talk more about this when you take CST316 that focuses on requirements. But anytime, like right now, me talking to you in this asynchronous mode, I'm recording a video, you're going to watch it later, different than a face-to-face conversation, right? Because I don't get your real-time feedback to what I'm talking about, your real-time questions. So we try to use other mechanisms, discussion forums and email and Skype to try and handle that. Same kind of thing in software. It's a highly collaborative discipline. So Agilists believe that if you're writing a document to try and capture requirements, to try and capture design, and so forth, that you basically have a lossy process. You're going to lose information no matter what you do. The best form of common understanding between human beings is to have a face-to-face conversation to arrive at that same mental common understanding of something, and then to act on that understanding. And we'll talk about that principle more in a following module that focuses on the concept of user stories, because that's what that's actually about. Additional principles, again, working software, primary measure of progress. I think we talked about that. One thing kind of related to the speed of things is Agile promotes sustainable, or what's really rhythm-oriented development. And I guess the way I want to say that is I want to keep in mind the word cadence. So if you remember, if you've heard the term cadence before, most people hear it in terms of a military marching band or a college marching band, that kind of constant rhythm to something, that constant cadence, as it's called. It's extremely important to Agilists, it's important in this class, to establish that regular rhythm, to try and be able to kind of turn the crank in a consistent, predictable basis. So it's basically saying instead of mapping out, individual tasks and estimating and work through, basically establishing something called a velocity of a team that says, here's how fast we work, here's how much stuff we can get through. And that's kind of Agile's way, or one half of the equation of Agile's way, of trying to deal with what has been a classic problem, why software projects fail, around estimating and tracking projects and being able to essentially scope and cost them out. Once you have your velocity down, once you understand at what pace that you work and how much work your team can get done, at least it gives you a notion of predictability that helps you manage your costs. Continuous attention to technical excellence and good design enhances agility. Again, you'll hear some folks say, well, Agile doesn't do design because it wants to go straight from the user story, straight to requirements to code. That isn't actually true. Part of the reason that we have these quality software construction practices closely associated with Agile is Agile goes beyond and says, technical excellence in writing code, being able to, when we do design, we do it we have a high capability so that we don't have a lot of rework associated with it. So for example, last class in 315, you would do UML modeling and you create these documents and so forth, and you were asked to do that. You'll be asked to do more next year. However, in a pure Agile shop, most of the designs are going to be up on a whiteboard. I mean, where I worked, we went and whiteboarded every single wall, and we did informal designs on the board in real time, but they were good design models. They just had utility for a shorter period of time, and we didn't want to take the time to write them down, to audit them, and over-review them, because that adds that overhead. Instead, we had the technical capability to be able to design kind of in a just-in-time way, and then be able to go code against that. In a distributed fashion now, that's done through things like wikis and so forth, so you can do that knowledge capture, but then rapidly move on. Simplicity. The art of maximizing the amount of work not done is essential. So that's a nice phrase, right? The amount of work not done. That's another way to measure your efficiency, or removing overhead, as we're calling it. When you can get to the same or even better quality software, but do less work in doing it, that's streamlining. That's taking and removing amounts of work. All right. So maximizing what you don't do while still being able to produce working and quality software is important. And that's a really interesting principle, and kind of one of those things that a team constantly has to ask themselves. Do we need to be doing this? Is this contributing to the quality of the software? Because if it isn't, we're going to get rid of it. All right. It's kind of a lean principle, if you will. The next one's kind of controversial. The best architectures, requirements, and design emerge from self-organizing teams. There's been a lot of study and a lot of discussion since the manifesto about the best way to construct Agile teams, cross-functional teams. Everybody in the team needs to have full scope skills, meaning needs to be able to do UI design, back-end system development, database, whatever. There are some different theories and different ways organizations do that. The other half of this, though, is architectures and design as emergent, and it kind of goes with simplicity. Agile it definitely believes in solving the problem in front of you in the simplest way possible, and not worrying about generalizing your design to solve a more general problem. One of the risks, and that was radical, because in the decade of the 90s, the unified process folks, and the folks who came up with UML, right? The unified in UML that you did in 315. I don't know if it was explained to you or not, but unified. It's called unified because there were three main practitioners: Grady Bush, James Rumbaugh, and Ivor Jacobson, who had the predominant object-oriented models, particularly Bush and Rumbaugh. And what they did is they unified their models. If you look at a pre-UML version of Bush's model, he used these cloud-based diagrams, and Rumbaugh used something more boxy that UML more resembles. Ivor Jacobson added use cases, still doing that stuff today. realized the decade of the 90s was about saying we're going to produce better software by having better software architects and designers, by using UML and the like and doing better design. And Agile came along and said, we're not going to do all that. We're going to do a design just in time. We're going to do it informally, and we're going to let it emerge. We're going to solve the simplest problems first and generalize, kind of bottom up, instead of saying we need a whole big architecture that understands its interfaces and locking that change down again. Right? That was the RUPS version, Unified Process way of managing change, was to come up with an architecture that no matter what change came up, it could still manage it within its scope. Agile said, we're going to go the other direction. We're not going to be top down like that. We're going to be bottom up. And we're going to start from the bottom and solve the simplest problems. And hey, as the next problem comes along that looks like it would connect to the problem I solved over here, I'm going to refactor. And we'll talk about refactoring. And an architecture and design will emerge. That is still, this whole notion of how much top-down architecture versus low-level refactor on the way up design is still an active topic of industry and academic debate today. 15 years later, it's not solved. People have all different kinds of ideas. Then finally, at regular intervals, the team reflects on how to become more effective, tunes and adjusts its behavior accordingly. Software engineering for a long time has had the concept of a post-mortem. You'll read one of the classic post-mortem papers. But post-mortems typically happened at the end of a project, not at the end, not at a regular interval. So the regular interval part's important because basically every single iteration, the development team is expected to conduct what's called a retrospective. And you'll do this on your project as well, where you'll reflect on how well you did, what kind of tweaks you need to do in the next sprint. So this feedback, all right? So far when we've been talking about tightening the feedback loop, we've been talking about tightening the feedback loop as it relates to the project, the software product that you're creating. Here what we're talking about is creating a tightened feedback loop on your process, on what you actually do every day and how you're executing your Agile method, and seeing if there are minor adjustments, Super Mario steering your process to try and get better. Principles, I've already talked about these in another forum. I grabbed this one because this is what it says. This table actually appears in your textbook. So I wanted to contrast it, but if you notice, we've already talked about principle of customer involvement. Customer is always present. Incremental delivery, incremental aspect, that decomposition part and delivering working software in an increment. The focus on people over process. By the way, you have a reading, an optional reading on Blackboard by Alistair Coburn on people as first order variables in a dynamic process, basically. It was one of those papers I read where I went, wow, what a great idea. We've been missing the boat. This guy hit it right in the head, that people are the most important part when we're studying process. Again, embracing change we've talked a lot about, and we just talked about maintaining simplicity. So that's kind of the Agile Kool-Aid. And so, hey, Agile does an empirical process control. It's going to tighten feedback loop. It's going to embrace change. It's going to put people first. Customers are going to be involved. We're all going to be happy, right? No overhead. Well, like anything, it's not that simple. There are some problems with Agile methods and some active areas that folks are trying to optimize, and even look at pushing the envelope forward in, like I mentioned, things like Kanban. That'll be beside the scope of this class. And it's also the reason why Agile is not used in every single domain on every single kind of project now. There are limits to Agile scalability. There's concerns over using Agile in safety critical domains, building an airplane, medical systems, weapon systems, things of that nature. But the reason why Agile is being used in those 88% of projects is developers and engineers are producing better software faster in a much more cost-effective fashion. So even systems developers want some piece of that and are trying to understand how they can customize Agile within their domain. This actually came out of your textbook, so I don't necessarily agree with all the problems that Somerville states, but I did want to put them up here and talk about them. First, Agile is more appropriate for new software development than maintenance, yet the majority of software costs in industry come from maintaining existing software systems. It's just a fact of life. You go get your software development job, and very often a junior software developer starts with, hey, go work through the bug list for this piece of software. It's the way you're going to get familiar with things, and we need these bugs squashed. development organizations do have to plan a certain amount of their time for dealing with bugs in their software, bugs post-release that come in from their customers, let's say, and having to go through and fix and release a patch or release a new minor version or whatnot. So that notion of maintenance always happens. I don't know if I agree with Somerville that Agile is more appropriate for new software development than maintenance. There are aspects of how Agile ramps up a project that actually some folks don't like. It's one of the things about Agile I don't like, starting new projects. I prefer to start them with more the rough inception and elaboration, and then move toward Agile when we get more development centric. Whereas in maintenance, when you have a certain set of defects or incremental requirements that you need to add to existing software, I actually think that's a great model for Agile, because Agile kind of has this consistent velocity that you establish, so you can kind of work through those maintenance issues on a consistent basis. And maintenance issues tend to represent some amount of change, a defect fix, an incremental requirement or an incremental feature, a kind of a new minor modification to your software. If you think of it as representing a form of change to your existing software, and Agile is going to be better at embracing that change. So I don't know if I agree with Somerville on that first point. Agile methods are designed for small co-located teams, yet much software development now involves distributed teams. That is absolutely the case. In pure Agile KoolAid, and if you look at an Agile organization, I have some pictures and some later slides, you're expected to work in a co-located space. In fact, if you go to an Agile development shop, folks don't even have offices. They work in what's called a bullpen, and I'll show you pictures of bullpens in future slides. Basically an open area where you're facing the other developers you're working with. So you can have these constant collaborative interactions as opposed to squirreling away in your office or not working in a co-located fashion. Further, you will need to have your customer right there with you, right? So imagine, hey, your customer is going to move their office and be co-located, so you can go talk to them all the time too if you need to. Again, is that really going to happen? Doesn't happen in a lot of places, maybe some internal IT projects, but really normally you have a proxy for the customer called the product owner, and you need that product owner's time though all the time, not just on iteration boundaries. So pure Agile kind of wants this small co-located team, but the reality is that's probably not doable for an awful lot of projects for various reasons. One of the reasons is a lot of software development happens with distributed teams. You're in a software engineering discipline. When you graduate, you're going to get a great job. Why? There's a huge demand for these skills, and so organizations have had to allow for outsourcing development, whether overseas or to another vendor. They've had to allow for allowing their employees to telecommute, and they've had to allow for, hey, I want to work for you, but I don't want to move to Phoenix, Arizona. I want to live in New York, or I want to live in Mississippi, or I want to live wherever. All right, and I want to connect in. Right, it's all virtual stuff. I have the tools that can support distributed development. I have websites, I have WebExes, and so forth. So I don't want to physically be there, and so that's why there's we'll use some of these virtual tools. We'll use an online Scrum board and the like. I use Skype with you for office hours. You're going to use Skype or Google Hangouts with each other on your team. That's just what kind of things that folks are now trying to do to allow for these very practical issues of identifying great resources to work in your organizations while still trying to be Agile. Bigger one to talk a little bit more about though, and we mentioned this notion of contracts before. The informality of Agile is incompatible with the legal approach to contract definition commonly used in industry. When you sit down and make a contractual obligation to somebody, right, you're promising a product or service in exchange for compensation for it. And as part of that contract, you define a number of things. You're going to define a quality measure, an acceptance test, a basis for an acceptance test. You're going to define when it has to be delivered. You're going to define your liability associated with it once you deliver it. You're going to define a warranty period. Once I turn it over and it's accepted and you put it into use, how long do you have before you can call me back and say, hey, this doesn't work? Just like any other warranty you get for a product you buy at a store. When you're developing custom software, and realize most software, a lot of software is developed under a customer supplier relationship. You go to a software development shop, a body shop as it's called, and you give them your requirements and specifications. You put out an RFP, and they respond to it. You give them the work. It's custom software development work. It's not software you go buy at a store like a video game. It's software that you want developed custom. So that in order to develop that custom system, in order to scope out the acceptance tests and how much money it'll cost and these other things we talked about to go into a contract, you need a specification. You got to study the problem. You got to understand the requirements, and you got to develop something that represents what you're going to deliver. Well, that's a specification. Well, the problem is we're back to almost a waterfallish kind of thing. I got to do a whole bunch of requirements and analysis work up front in order to get that spec, so that then I can sign the contract. But Agile believes in kind of doing this in a much more concurrent, evolutionary way, interleaving the specification and development. And so now the nature of a contract's different. So most Agile projects I work on in industry, have worked on and consulted on, kind of use a hybrid approach. There's an upfront assessment style activity for some period of time appropriate, but it doesn't go all the way toward writing this big document that represents the specification. Instead, it says, okay, here's kind of how big the box is we need to build, and instead we'll define a contract and an Agile concept to be more. We're gonna identify the capacity we need over how many sprints in order to produce a release that looks like that box. But we're going to agree that there's an embrace change in the contract. That's not normal in a contract. Most contracts, if you ever worked with government systems, for example, you normally have to go through a very formalized change request. My first job out of college was in the area of military systems, and so I became familiar with an SCR, a software change request. In a software change request, you had to write a document that was a formal change request that had to get signed off by everybody and his brother in order for you to go forward and do the work. And everything had to be re-scoped out, and how was this going to affect the cost of the contract and everything else. Agile basically says, we don't want to deal with that because we're going to embrace change. We know that's going to happen, so I don't want to write an SCR for every single thing. I want to embrace that change and instead have a contractual a contract vehicle that realizes we're going to have that kind of churn. Now that's not the easiest thing for contract people, and your bean counters aren't necessarily going to be happy with that. So it's a different kind of vehicle. It's something that folks are coming around to now, though, because they realize overall they're getting more cost effectiveness. But it also relies on a lot of trust on both sides. I mean, when you work with a trusted vendor, as a customer, you feel a bit more comfortable because you kind of know that this churn is real, that they're working in good faith through that churn in order to deliver the best working software that they can, which is different than, hey, I don't know you, but I'm going to promise I'm going to give you this in this date. Well, too many contract deliverables couldn't be met in industry. There were too many lawyers involved. So now new contract ways are emerging as together with the Agile community. So that's kind of the pros and cons. That's the KoolAid talk. That's, we didn't get into any specific mechanisms around what Agile is. That's going to be next. Next, we're going to talk about Scrum and the particular machinery. And you're going to do Scrum in your class project, so that will be important. But this is more how Agile relates, what the philosophy is, what the culture is. There's a lot you can read about this. There's a lot of discussions you can have with practitioners in industry over it. I was just trying to give you that initial KoolAid of why it's become popular. And now that we have that, we can move forward and get more specific.